Dear students, today we'll see what do we mean by a twisted pair cable, which comes under a guided media and which comes under as a subtopic for a transmission media. So in a transmission media topic, we will see what is a guided media, and then in that a guided media, the a twisted pair cable is one type of a guided media. Like you can have a coaxial cable also, you can have optical fibers also. So today we'll see what do we mean by a twisted pair cable, and in that what exactly it is, what is a twisting, why do we require a twisting, what are the types. Like you can have unshielded a twisted pair UTP, you can have shielded a twisted pair STP. Okay, and then applications of that, and then we will compare STP and UTP. Okay, so let's start with the topic, and first we will see what do we mean by a twisted pair cable. Okay. Now, if you go through the definition, it says that a, a twisted pair cable comprises of two separate insulated copper wires. Okay. These are the conductors, two separate copper wires, which are twisted together and it is running in parallel. Okay, so they are twisted together and run in parallel. The copper wires are generally, it is 1 millimeter in diameter. One of the wires is used to transmit data, and the other is the ground reference. That is what a general twisted pair cable will have the notifications. Okay, so here, if you see, we have shown the diagram here. So here you can see some pairs of hot twisted. So here you can see you can have this hot twisted wire, one pair. This will be another pair. This will be another pair. This will be another pair. All these pairs are put in a sheet, insulated sheet, and then it has been it is going to carry your data or your signal from one point to another. Okay, so these pair, like if you take individual pair, so you can see that one wire or one cable will go like this. Okay, and the second one will go like this. Okay, so that is how you say it is twisted. So here at the end you can open it, the top insulation you can open, and you can get the inner conductor which is made up of copper. So here also you can get, and here also you can have the inner conductor of copper. Here also you can have the inner conductor of copper, and these are the twists. So whatever you do here, these are the twists. Now these twists are important because we come to a basic theory that whenever a conductor is going to carry current, whenever it is going to carry a current, it will develop a magnetic field around it. Okay, it will develop a magnetic field around it. This is your internal field, which is because of the passing of current through the wires or cable. Okay, you can also have external field which can come from outside area and can interfere your data, which is, or the message or the information or the electrical signal which is traveling through your cable. Clear? Now that should be eliminated. Now to eliminate that, if you twist this wires here, so okay, if you twist this wires here, then the magnetic fields of the noise, whatever is there, will get into opposition and they get cancelled out. And that is how one process, this is one of the process of twisting the wires, by which the interference or noise which is generated can be cancelled out. Okay, so that is why we twist the wires. Okay, so in this twisting and in this type of cables, we can have unshielded twisted cable. We can also have shielded or twisted pair of cable. Clear? So UTP and STP. Then we will see the theory behind why do we require actually hot twisting. So reason for hot twisting. All our transmissions are prone to noise. Okay, so whenever you transmit a signal from one point to another, it is going to face noise. It is going to be interfered with noise. Okay, so noise, interferences, and crosstalks. Okay, so all transmissions are prone to noise, interferences, and crosstalks. So when the wires are twisted, Some part of the noise signals is in the direction of the data signal, while the other are in opposite direction. Thus, the external waves cancel out due to the different twists. The receiver calculates the difference in voltages of the two wires for retrieving data. Thus, a much better immunity against noise is obtained. This is one theory for your twisting. We can put this theory in another way also. The pairs are twisted to provide protection against crosstalk, the noise generated by adjacent pairs. When electrical current flows through a wire, it creates a small circular magnetic field around the wire. That is what we told as a basic theory. When two wires in an electrical circuit are placed close together, their magnetic fields are the exact opposite of each other. Thus, the two magnetic fields cancel each other out. This is very important. They also cancel out any outside magnetic fields. Or twisting of the wires can enhance this cancellation effect. Okay. So here twisting is going to encourage that cancellation effect of magnetic. So using a cancellation together with or twisting the wires, cable designers can effectively provide self-shielding for wire pairs within the network media. Now, this is also one way to put the theory that why do we twist the wires. Now, this twisting theory can also be told as the two wires are twisted about each other so that each is equally exposed to the interfering signals picked up from the environment. Okay, now this feature we can explain when it is important when the differential transmission is used. That means when the two wires are carrying the two voltages, say in one wire there is voltage 1 V1 and another wire there is voltage 2 V2. So if two wires are going to carry two voltages, then the output what you want to take is the difference between the two. That will be called as differential transmission. Okay. So in that we can show how this noise get cancelled. Okay. How this noise get cancelled because of twisting. Clear? So let the signal 1, that is the voltage 1. Okay. So let voltage V1. Okay. Voltage V1 is been applied to one of the wire. Okay, is applied to one wire. Okay, one wire. And let voltage V2, let voltage V2 is applied to the other wire. Clear? Now here, let each wire face a noise voltage called as Vn. Okay, let the each wire face a noise voltage called as Vn, and we want the output to be the difference between the two voltages. So we want output voltage to be V1 minus V2. Okay, now here in the figure you can show that this is one wire. Okay, and this is another wire. So one wire is going to carry V1 as voltage and another wire is going to carry V2 as voltage. Okay, so the output voltage is V1 minus V2. So here we have shown V1 minus V2. Now here let noise be added to each wire. So then when noise is added to each wire, then it for V1, that is the one wire, the first wire, it will be V1 plus noise voltage. Okay, and for the second wire it will be V2 plus noise voltage. Clear? Then if you take the output voltage, then if you take the output voltage, then it will be V1 minus V2. So now V1 is nothing but V1 plus Vn. Then this is nothing but minus V2 plus Vn. Okay, Vn. So here if you open up this, it will become V1 plus Vn minus V2 minus Vn. So Vn will get cut and what will remain is V1 minus V2. And that is what we want output voltage as. Output voltage, we want it as V1 minus V2. So because of twisting, we can show that the noise which is added for a differential transmission that noise can be eliminated. Okay, so this is also one way to show the hot twisting of wires. Okay, then we'll go to see then how many types of hot twisted pair cables are there. As I've told you earlier, the first one is called as unshielded twisted pair UTP. These generally comprise of wires and insulators. And the second one will be shielded twisted pair STP. They have a braided wire mesh that encases each pair of insulated wires. Okay. So both are actually same type, but only in the second one, that is STP, on the pair of wire, you are going to have a wire mesh which will again protect it more from the electromagnetic field. Then this is a way to show how the wires can be twisted. Okay, so here you can see the blue wire and the yellow wire are twisted, and this is how your twist cable. This is a twist. This is a twist, and here also you can see a twist. Okay, here also you can see a twist. Okay, this is how the twist will make it more effective to cancel out the noise. So here you can have your copper conductor of 1, here you can have your copper conductor of 2. So this will be your wire 1 and this will be your wire 2. Okay. So in this way you can twist the wires. Now if you see the schematic of that, then you can show it like this. You can have one wire and second wire which are twisted. So here again you have shown the twist. This is the twist. This is the twist, this is the twist, and this is the twist, and each wire you can have the solid copper conductors which can be taken out if you just remove the top insulator. Then here also you can see the second copper conductor. Okay, and upon this copper conductor you are having the outer insulator or the PVC, polyvinyl chloride. Then unshielded twisted pair cable. Then as we have seen in Ethernet or networking, whenever we do LAN connections and all, we use cables like Cat5 and Cat6. So in that you can have some four pairs of wires. So here you can see you are having one pair here. This is the first pair, this is the second pair, this is the third pair, and this is the fourth pair. And in every pair of wire, it is twisted pair. This is twisted pair. This is twisted pair, and here also you can have a twisted pair. Here also you can have a hot twisted pair. Here also you can have a twisted pair. So this is how you can have your networking cable which can be used for Ethernet to build up LANs. And this is the way you have your unshielded twisted pair where all these wires are just covered by an top insulator or a PVC. Okay, it is made up of plastic. So the top insulator is there, and that is going to just cover up the pairs of twisted wires which are inside. Okay, so this can be called as a cable which is used for networking, Ethernet cable, and that can be used in your LAN networks, whatever you make in your labs. Then we'll go to see what is exactly the theory of UTP. UTP is the type of twisted pair cable. It stands for unshielded twisted pair. Both data and voice are transmitted through UTP because its frequency range is suitable. So data or voice, both are your basic information signals. Both can have a frequency range which is suitable with the UTP frequency range. Okay. In UTP, grounding cable is not necessary here. Also in UTP, much more maintenance is not needed. Therefore, it is cost effective. The cost is not that much as you require for STP. Okay. So here, UTP cables are often groups of twisted pair grouped together with color coded insulators as we have spoken about category 5 and a category 6 type of cables which we use for LAN, that is the Ethernet cables, the number of which depends on the purpose of application. Then when to use this unshielded cable? Now we know that there are two types of twisted pair or cable. One is unshielded and the other one is shielded. But when we are going to use this unshielded? So unshielded cable UTP does not utilize shielding to reduce interference. So here you don't have an extra shielding as you have in STP. Okay, so here you don't have an extra shielding for to reduce the interference. UTP cables are designed to limit electromagnetic interference by the way the pairs are twisted inside the cable. So only the twisting effect, whatever is there, that is going to enhance you to make the electromagnetic interference limited. Okay, so that will only limit the electromagnetic interference. Apart from that, you don't have any other measures by which you are going to have the reduction in the interference. Okay, so UTP cable is most suitable for office LANs, local area networks, and similar network cabling systems, while offering less protection from interference as compared to shielded. Okay, this statement is as compared to shielded cables. So while offering less protection from interference, unshielded cables are popular because they are, these are the features now why they are so popular. So these are the advantages: because they are versatile, they are inexpensive, they are easy to install, they are light in weight, and they are flexible. Okay, so these are the advantages of why do we use UTP. Okay, the main disadvantage of UTP cable is their susceptibility to electromagnetic interference and radio frequency interference. They also have a smaller bandwidth as compared to coaxial cables or fiber optic cables. So these are a few disadvantages also, but there are many advantages. So it is used in many offices and many buildings and many schools and many homes wherever you want this local area networks to be formed. Then what are the applications of UTP? Then specifically, if you want to say, UTP cables are widely used in the computer and telecommunication industry as Ethernet cables and telephone wires. Okay. Then what do we mean by STP? So STP full form is shielded twisted pair cable. Now this configuration, this arrangement will be same like your unshielded one. Only thing, what extra thing will come will be this casing of the mesh, whatever you are going to put above the twisted pair. So these are your twisted pair wires, which are same like your UTP wires. So these are your copper outputs out by outside the copper conductors, and upon this wire you are having this mesh. Okay, this mesh which is going to protect these wires from electromagnetic interference. Okay, any outside interference. Okay, and upon that the normal plastic cover, that is PVC cover, will be there. Okay, which will act as an insulator. Okay, so everything will be same except that the mesh what you see in between, this mesh is extra here in shielded twisted pair. Now if you go to see the theory of shielded or twisted pair, so shielded or twisted pair STP cable was originally designed by IBM company for token ring networks. Okay, token ring networks we have studied in our data communication and networking. So that include two individual wires covered with a foil shielding which prevents electromagnetic interference, thereby transporting data faster. Okay, so there are two things. You have to prevent electromagnetic interference also, and you have to transport the data faster also. Then the other theory for STP, so here you can see that STP is also the type of a twisted pair which stands for shielded twisted pair. In STP, grounding cable is required. This is one more important point. Okay, in STP you require a grounding cable, a cable which is connected to ground. Okay, so a grounding cable is required, but in UTP grounding cable is not required. In STP, much more maintenance is required. Therefore, it is costlier than UTP. Okay, so STP maintenance also is more, and its cost is also more as compared to UTP. And the earlier point, what we told is grounding cable in STP is required because that extra mesh, what you're going to put, okay, around the pair of wires, that can pick up noise. Now that if you want that problem, if you want to sort out, then that should be grounded properly. That is why you require a grounding cable in STP. So when to use shielded cable? Okay, now when you are going to use shielded cables, now shielded cables are useful in any environments where there is a high chance of electronic interference. This is very important. Whenever a field is there, whenever an application is there where there is a high chance of electronic interference, such as radio stations or telecom or cable assemblies, and airports, aerospace cable assemblies. Okay. STP cables are also used in security systems to provide protection from power frequency and radio frequency interference, or in box builds where there are multiple different components operating in close proximity, as well as being protected from external interference. The shielding also keeps noise from exiting the cable, minimizing the chance of causing interference in other devices. So this is what tells where you can use this shielded cable. So these are used in areas where there is more chance of electronic interferences. So there you have to use shielded cable for all your networking purposes. Then if you go to see applications of STP, they are used in security systems to avoid radio frequency and power frequency interference. This helps reduce the number of false alarms which may be otherwise disturbing. STP cables are also used in recording studios or public address systems. A twisted pair cable helps assure a balanced audio configuration. The STP are also used in box build applications where different components are working close to each other. So even there, the interference can be avoided because it is a shielded cable. Then exactly when you see the configuration, how does the configuration or the arrangement look for a UTP and STP? So the first figure here shows a UTP arrangement. So here you can see UTP arrangement. So here you can see this is one wire, this is one wire, this is one wire, and this is another wire which are twisted, and here you can have your copper conductor which can be used for your connection, copper conductor, which can be used for your connection. And upon this arrangement of twisted pair, you are having this plastic cover. So this is simple. This is your unshielded twisted pair cable. Okay. Similarly, if you go for STP as shown in the second figure, this is your STP. So arrangement is same. Here you are having your twisted wires. Okay, so these are your twisted wires. Here you are having your copper conductor, okay, copper which is there inside the insulated wire, okay, and upon that you have a metal shield. This is a metal shield, this is the mesh, this is a metal shield. Now this is an extra thing what is there in STP. Because of this shielding, that same arrangement which was used for UTP, because of this extra shielding, it is called as STP, that is shielded twisted pair of cable. And upon all that arrangement, you will have the same plastic cover as you had in your UTP. Okay, same a plastic cover as you had your UTP. So STP is having an extra thing, which is this metal shield, which is there on the twisted pair cable. Now this shield will see that the electromagnetic interference is reduced a lot as compared to UTP. So STP cables function by drawing external interference to the shield, then getting rid of it into a grounded cable. If the ground cable is not properly grounded, STP noise cancelling functionality can be seriously compromised. That is why that grounding cable in STP is important, because that has to be grounded properly. Otherwise, the extra mesh whatever you have put can pick up the noise, and that noise can interfere. So that particular point should be grounded properly. Then after this whole discussion, if you go to see the difference between the two, that is UTP and STP cables, then you can form it in this way. First point, we'll take the full form of both. So the full form of UTP is unshielded twisted pair. Similarly, the full form of STP is shielded twisted pair. Then whether grounding cable is required or no, we know that UTP will not require, whereas STP will require the grounding cable. Then what about the data transmission rate? Who is having faster, who is having slower bits per second? So here we can see data transmission rate is slower than STP in UTP. Okay, so UTP is having slow data as compared to STP, and STP will be having little high data as compared to UTP. Then if you go to see the cost, UTP cables are cheaper and STP cables are expensive because that extra arrangement is there of the mesh, whatever you use to avoid the electromagnetic interference. Then if you go to see the maintenance, so low maintenance cost in case of UTP and high maintenance cost in case of STP. If you see the effect of noise, so effect of noise is little more in UTP as compared to STP. Noise is quite less in STP because of that extra arrangement what you made. That above the hot twisted pair, you are having a mesh which can avoid the electromagnetic interference. Then what about the crosstalk effect? So possibility of crosstalk is higher in UTP and possibility of crosstalk is lower in STP because of the same reason, because there is more arrangement of avoiding the electromagnetic interference. Thank you, students.